Right, shall we start? Good afternoon, everyone. Thank you. My name is Kenneth Tan. I'm from Sardina Systems. I want to talk to you this afternoon about clouds, toys, production, and enabling transformation through innovation. So, just to set the scene, a little bit of background about Sardina. We are an OpenStack vendor building integrated cloud platforms, focusing on full lifecycle automation. Today, we're primarily a European-focused company with people in the UK, Romania, Slovakia, Russia, and the team mainly came from HPC in the early days, and today, folks who come from defense, telco, and finance as well. And along the way, we've picked up a few awards and partnered with a range of hardware and services players across Europe. So, looking at clouds, what's the objective and what do we need? Broadly, with the cloud, we're looking for speed of execution, reliability, flexibility, and cost efficiency. Yes? Good. Nothing unusual, right? And from a user's point of view, why does the user want a cloud? Want something that's quick to get going, something that's easy to reconfigure, programmable, and from the manager's point of view, looking for execution speed in the sense that it's easy to consume, no need to spend weeks on end to discuss with the infrastructure team on what exactly is needed, what needs to be configured, what needs to be provided, so on and so forth. And also, it's a layer of standardization so that when it comes time to recruit new talents to join the team, it's easy to get from zero, i.e. day one, to a point when a person is in a productive state. And then, what about reliability? It should just work. That's it. Flexibility? Well, wanted to cater to a broad range of users, broad range of projects, and organizational requirements. Yeah? And now, when it comes to cost efficiency, there are two elements to it. There is the OpEx, CapEx part, optimizing both OpEx, CapEx, and as well as best use of people. And if we delve further to look at cost efficiency in relation to data center resource usage, broadly, we want it optimally managed and want some ways of maximizing server utilization. And now, in relation to server utilization, my only question is it sensible to allocate one VM per core? But regardless, are we really building a shiny new toy? Absolutely not. A cloud should not be a shiny new toy. It's a production system. So today, I want to draw view from a number of implementations across European R&D facilities. They're broadly in research and academic sector. Looking at the computing challenges across these organizations. So invariably, with these sites, what they're looking for is a flexible compute infrastructure to serve a broad range of requirements, broad range of projects. You ask the question, can we mix technical computing workload and HR workload? Can we? Maybe yes. Because the underlying infrastructure should be broadly the same. If it is done right, you can mix them. And with these projects, what you also want to take advantage of is the on-premise cost advantage and on-premise security. And here you're going after the reduced time for execution. So without going into specifics of certain customer sites, it is possible to deliver a unit of compute resource, which Amazon sells at 10 cents per hour, at 1 cent an hour, and you're still making positive margin. So in relation to cost advantage, on-premise cost advantage, no doubt you can beat that. Yeah? And so this environment, there is a mixture of traditional VMware environments, bare metal, some traditional HPC as well. And what the clients look for is to get to a self-service, rapid turnaround system, and to get away from this service tickets-based approach. So one of the organizations, their pre-existing environment, in order to implement a particular change, it basically goes from somebody sticking a service ticket into the ticketing system, and it gets passed around the organization, and by the time it gets done, it gets passed back, that whole chain. You're lucky if it's 2 weeks. If you're not so lucky, 2 weeks later, you get a response back saying, yeah, your original request could not be met. So you're back to square one. And from a client perspective, we want to get from 0 to time to execution within 2 weeks, as in the entire system up and running into production-ready state in 2 weeks. And this sort of environment, not only that we want to provide the users with a very easy, very quick to get going, flexible environment, but also very critically for the organization's operations team, it should not be a net increase of workload for them. It should be another easy-to-operate system. So within this sort of environment, there's another very important point. It's that we can't make assumptions about the end user's technical capabilities. And in some environments, no, you cannot ask the users to call an API. Yes, it is indeed to that level. But what you can do is ask the user to go point and click. Yeah? And then if you then zoom back out to the organization level, we need to meet the organizational mission, and no, we can't throw money at the problem. Yeah? And so now, what we then did was that we go from these high-level objectives to look at what's the client technical requirements. What is the solution to be implemented in this situation? And what can the solution do? How much does it cost? What's the operational training required, if any? And then we take the client through infrastructure planning prior to a deployment and testing, and then we get to a first user on board. Now, as for planning for hardware, we're going to be looking at what's the hardware requirement, what's available in the existing pool of hardware. If we can reuse some hardware, fantastic, because we've just dropped the overall cost for the client. And what's network configuration required as well. So, and then coupled with this, we're looking at how do we scale up. That scaling up process should be monkey capable. Press button, scale up any part of the system. And so with this, then we then implement a solution architecture that enables us to independently scale up any of those major blocks that you see there. And this is one where we have HA as default. HA is not optional. And we can do stretch capability across multi-site as well. In one of the, in actually two of the sites we came across, a particularly interesting situation with the hardware supplier. Basically, the conversation was along the lines of the client decided that, we need to buy additional self-storage. So the client rang up the storage supplier, i.e. the hardware vendor, and they said, so we want nodes for self-storage. And the hardware vendor said, so what exactly do you need? And the client said, we need self-service. Okay, so what do you need? And this conversation basically went back and forth, back and forth. At which point we stepped in. We provided the client with the full BOM, i.e. with the part numbers of that hardware vendor. And the client took that BOM, told the hardware vendor, we want 3 copies of that, 5 copies of that, X copies of that. When can you deliver? And bang, the hardware vendor provided a quote within an afternoon, and kit delivered by the end of the week. This was after they spent about 3 weeks going back and forth. And so once the hardware is in place, we get the system up and running in a relatively simple manner. So our approach here is to rely on the organization's base OS deployment system to deploy the base OS. And once the base OS is up, FishOS deployer comes in, an Ansible-based tool to get the system running. The agreed period is usually about 2 weeks, but then very often we get the system up and running within a 24 hours turnaround period by one person. So once we have the system up running, then what? The operations team gets training and familiarization within 2 weeks, understanding how to live with the system, and first user on board by week 3. And the system also supports Kubernetes via Magnum. So, all right, now that we have the system deployed, then what? Now we're into problems. We're into challenges. We've got to deal with resource management, health management, monitoring, log management, accounting and billing, service management, capacity planning, so on and so forth. What do we do? Here, I want to touch on one part only. I'll touch on the matter of reliability. How do we keep it up? So the objective of keeping it up really is to prevent the user from screaming incompetence on the part of the operator. So these days, there are more and more users who grew up in the Amazon era. Their experience thus far in relation to computing is basically go to Amazon, point and click, yeah, I've got a VM. Wonderful, I can now code. So said young coder shows up at work, and the operator says, the cloud is down today. So what is the user going to do? He screams, "Oi, you lot are incompetent." Yeah? So the objective of reliability is to prevent screaming of incompetence, in effect. So the expectation of the user is it should be up. Always. Simple statement, simple objective to state. And then we look at how do we deliver that? If we look at traditional monitoring, what is it actually looking for? The principle behind monitoring is quite simple. Is it up? Is it alive? You probe. Is it alive? Next cycle, you probe. Is it still alive? Yes? Good. Next cycle, it's not responding. Let's probe 3 times. Is it still alive? Not responding. Fine. Let's declare death and call the operator. But by the time we do that, the user is going to be screaming incompetence. No good. So in relation to the cloud ops requirement, therefore, our objective is to figure out the 6 states, not the dead states. We want to know when the system is ill so that we can prevent death. And no, we cannot redefine 6 states as death. Imagine this. If we redefine sneezing as death, there'll be a lot of sneezing people in the ground, buried 6 feet underground. Not necessarily a good thing, yeah? So here what we do then is we conceptually form pictures. We take in volumes of data, and we form these pictures. So think about it this way. Let's say we have a bunch of patients. We put the patients through an X-ray machine. And on the other side of the X-ray machine, we've got pictures, yeah? And we then put the pictures through a classifier. And with that, we detect whether it is a picture of health, picture of sickness. Now, does it matter if it's a picture of the chest or a combination of the head and the foot? Not really. It'll detect for anomalies. And then once we detect in a situation of sickness, we can then take actions. Yeah? What about emergency room situations? For example, we detect that power supply unit is sick. Do we want to take risks with a power supply unit being sick? Absolutely not. We can't wait and alert, can we? Because if the PSU goes kaput, the workload goes kaput, at which point you have the user screaming, "Oi, you lot are incompetent." No, we can't have that. Yeah, so that's what we need to prevent. So to keep the workload going, we therefore, once we detect the PSU is about to die, we flush the workload now. And thereby keeping the workload going. But you then have the question, how do we flush the workload at all times? Can we do that? Are there situations when live migration doesn't work? And if so, how do we then ensure the live migration completes? And here, you've got to look at the reasons why the live migration isn't completing. And then we can take actions against it. And so this is where we have a set of heuristics to understand what could be the reasons. And that allows us to then take the actions accordingly. So this is, in effect, what we deliver through our product, FishOS. And the system then embodies these concepts of how do we enable HA, how do we enable smart resource management, how do we enable smart health management, all as a single product, easily consumable by a site without having to engage in months and months and months of consultancy just to get it up and running. Some of the sites in the UK, in Germany, and elsewhere, including US and US, Russia, Norway. The Norwegian site is quite interesting, where we effectively brought up system within an afternoon. Base OS up by 1,400, and the full system up by 1,700. The top right, that's a machine learning cloud with GPUs integrated. So what we can summarize this to be is that when we're implementing an OpenStack cloud, let's not focus so much on how do we, not just how do we deploy, it's how do we live with the system going forward? How do we optimally manage the system? How do we manage the system in a smart way without having to deploy tons and tons and tons of people? And to finish off, anybody wants a free system? Today, at the event, one free system per industry, per country. Come talk to me, drop me an email. Thank you. Any questions? I think we've got a couple minutes. Nope. Thank you.